My name is David. I used to be in Korea many times and in this kind of conference many times. I was sending a video last year for talking about a multi-axis vibration for the presentation. This one is not. It's working.
Yeah.
Cool. So today I just pick up some different angles about testing, because we test every packaging we design, but we always find something wrong. If everything's okay, so we are all happy, but we have some unhappy things happen for your packaging being designed and tested as not get the result you want. So this is something we will talk about today. Okay. First of all, we talk about ISTA testing. So ISTA testing protocols, they have different levels to make something we call non-simulation. Some of you are testing your packaging with a mechanical shaker, with a fixed frequency, and just bounced on the shaker surface and then tested the basic performance to protect your product inside. For example, there's a toothbrush. So you have a toothbrush, which is, you can drop whatever, you can do that, but they will not damage. But if this is a lamp, a bomb, or somewhere, and you can drop it, you can easily damage. So we were make this kind of testing not enough, so we go next, we're general simulation. So we have a general simulation, a standard, which made by general signals, general data from the transportation and make up this kind of standard. So we're not good enough because they still have some problems, issues. Like Eric just said, after the research we found all the roads to the Europe, to the United States, to China, to Korea are the difference. We try to find a difference. We also try and find a difference for the e-commerce, the L standard, to see what this specific delivery give us a problem. So we have the final and the enhanced testing procedures. This will give us exactly what we want. So don't panic for if you want to use this one or that one or this one. But if you're looking for a perfect packaging testing, we go to the enhanced simulation. You will see exactly your future environmental. You will see exactly the protection to your product with the test protocols. So the question is coming, which one is suitable for me? So let's see. We talk about the data. In this morning, in this afternoon, we're thinking about data of transportation, which is the real data you collect from your transportation and use the data to do analysis to find out what's happening during the transportation environment. So this is the data we need. Use the data, create enhanced simulation for the test standard. You will do the protocols, and finally, you will see this testing is telling you how good you are for your packaging design. So this testing including compression, vibration, shock, drop, bump, multi-axis testing, whatever. All those testings have been done. After that, you should have the good result. Your test is passed. You give a certification. You are stamped for okay. You have steps. That's the stamp we just showed is the testing standard with the ID numbers there, and then you are safe. You're done all the tests. Show your customer we're a good packaging. If it's not passed, it's failed. how should I do? So today we're gonna bring some ideas for how should we do if we test failed from the ISTA test procedure. The test failed, it's not saying the bad packaging. Sometimes you have a little bit need to be optimized. That's why we say we got to optimize our packaging with the test result. We take the procedures. I take this perfect procedures, which is more complicated, with ISTA Series 6 Amazon. This is Amazon test for 6 series ISTA for e-commerce, typical in an inner controlled transportation system. So we found 2 failing points, which is highlighted for one is the free fall drop. Another one is a vibration. The vibration in the 0.54 GRMS random, they failed these 2 tests. So we take these 2 as example for, okay, now we think about how to avoid these failures. So we put only part of this design for your packaging. We're worried about cushion because drop, make your product fail. The key problem is a cushion. So shock is a killer, okay? Impact is a killer. So we need to think about shock. So the vibration 0.54 GRMS testing failure, also you think about the vibration transition because of the cushion materials to give you a generated more amplitude of your product, the vibration levels you can bear. So this is also another problem. So we think these 2 directions. So everyone sit here, understand why we need packaging. If the product is complete rugged, so we don't need packaging. We just need to wrap it and ship it. Maybe a hammer. We don't need packet. You hit everybody, not self. But every product, they have their own level of fragility. So we have to protect it, the product with a good packaging, a good cushion, to protect the product, to avoid the damage. This is what we are here. So the best way is cushioning. So if you drop a glass down to the floor, if it's concrete, it will broken. If this is soft with a cotton, you drop it on the cotton, maybe not broken because the cotton absorbed energy. So we need a cushion material to absorb the energy. But for now, we should think about how much cushioning we should have just about to absorb this energy. So we will first take out the data from the drop tester. For the vibration, the killer of vibration is the fundamental frequency. So every structure, they have their own fundamental frequency, we call FN, the nature frequency. If any frequency reached the nature frequency, we call a piece of metal will become jewelry. They were soft. They can be shaped, anything. This is the something that a physical professor will tell us. So we just watching these 2 points regarding to these materials. Point. So we found the drop test. So shock is the bad one. They can damage your product just in sudden. We call the transient signal, the transient impact to your product if the cushion is not so good. The packaging, they can bear a high acceleration, but can't bear the short duration. So if the higher acceleration with a short duration, like the one here, this is a real shock. It will kill your product easily. So one of our customer called Westpac in the US, they draw this typical curve. They shown the cushion is doing something like this to make lower the peak, the longer the duration. But the integration for both poles, here, is the same energy. Even it's the same energy, but where the other part to get into the product, because the cushion material, they absorbed the energy for you. So that's what we want to find out, okay? So this is the very typical procedures in a 6 steps packaging design, which is the second step to pick up the cushion materials. So we have known the product fragility already with some other testing. Now we see what happened. Which kind of cushion material should I choose? So we have a typical cushion dynamic curves shown on the screen. The first one is the foam. It's typically EPE foam. This curve is presenting a 2-inch EPE foam with certain drop height and the pressure. And we can see the different shape of foam there, which is the airbag. They have a different curve shape. And we also have the pad absorption. The pad is hotter. You can see the curves is almost linear. So this is 3 different kind of cushion materials for the protection. Depending on what kind of product, the weight, size, whatever, you need to choose one. So we do example. We try to see, okay, we have a 30-inch drop height, and we drop our packaging to the floor. We found a damage. So now we definitely will go 30-inch height, but we change the cushion materials. Then we find this foam. We found this foam dropped in a different load, sorry. The different load here for the foam. So the drop on the foam with different load, they have achieved these different points, the curve. But every drop is from 30-inch height. So if you get this foam, then you find your product fragility standard. They have a corrosion acceleration level. If the product cannot bear anything over 50 G, please do that. And then, so we have this AC here. It's the level, the ACs. So that's the maximum acceleration we can achieve here. So we make the acceleration AC align here on this curve. This for 30-inch drop with 2-inch thick EP. So we get these. Then we found only this period foam can be used to protect my product. So we will check, if my foam, 2-inch foam, is good for which load. So if my product load is just in this range, So we can use the 2-inch foam to make the right protection. So all the foam curves, it's only this piece of area can be used. So this is the cushion material selection with the test result. Okay, those tests, it's easy to find procedures in the ASTM standard. So the cushion test is ASTM D332, and you can find it in the tested materials. Most of suppliers of foam, they have this curve. When you purchase the foam, you can ask, do you have a dynamic curve for every materials? They should have a book and show you this already. It's existing. Sorry. So next, we will do a check with how the vibration gonna work for the cushion materials. So we just talked, vibration is very bad in your nature frequency. This table also have nature frequency. If we hit the frequency of the nature frequency of the table, clapped. It's in pieces. But if we protect it, we never hit the nature frequency, your product is safe to get away from the vibration heard. This is what we're gonna find out, okay? So the FN, to protect the FN is the goal. So there's a little rules for this is please think about to make the whole packaging system FN 3 times lower than the product fundamental frequency. So if the fundamental frequency of your product is 50 hertz, divided by 3. If your whole system frequency is lower than that frequency, you're good. So we want to make this as well. So we also test the cushion materials. The cushion materials also with 2-inch different 2-inch foam and with different density. So we have the density different. They come out with the 3 curves. So we have the 3 points, you know, the FNs like this way. So we have tested in a different weight. They get amplified to a zone, and also this is a derate zone, and this is up zone. So we need to find out this zone here, the frequency. This is FN. So this is a damage place. So we should avoid this zone, and we go this way down. So if the 1 to 1 zone, which means if the frequency is not being generated, if the altitude is not being generated, if you input 1G, they will react 1G. It's okay. This zone, we call it 1 to 1 zone. If this one come there, if you generate 1G, they may be like 10G. So your product will be damaged if your product can't bear 10G vibration. So that's the major point we're going to avoid. So let's move this frequency zone down. So you see that? At least down to 1 to 1 zone. So you remember, our test was 0.54G RMS, but it is RMS. So the peak G is at least 2.5 to 3 times of the level. So if this is 3 times, it's gonna be 1.5G. So check your product range and see if your product can bear 1.5G peak. So which is something we're gonna consider in the vibration. So in this time, we pick up the frequency for one. If we pick up the 1 to 1 zone, so we choose one of these materials. So we choose this material for a vibration purpose. So in the vibration testing, we must care about the spring mass mode. So if in the FN, they will generate higher the springs, so which means the vibration acceleration will getting higher. So we know such kind of profiles like this one. It's typical 2 peaks for resonance for the fundamental frequency. So we will definitely avoid this with someone. We got a frequency being here is safe. We can't generate here. So that's the. This is also a standard we can use. Is ASTM D3850. If you can test it, your materials with that standard, you will definitely get that curve, and you can use anytime you pick up to protect your product like that. Okay. So the key frequency, we know that, but sometimes the standard can't cover everything. The protocols cannot cover everything like we did say. But sometimes you have the standard testing which covers different frequencies, like this one. ISTA testing is ISTA pickup and delivery. They have 1, 2, 3 flat peaks. So during that 3 peaks, you are in the dangerous zone. So avoid that frequency is the key. Here's a little examples, if time is allowed. We have tested and measured for different packaging, but for same product packed, for C containers. We use the airbags, and we use the high density EPE foam isolation in the pallet. 2 materials difference. We try to understand for shock and vibration, these 2 kind of materials, how good they are during the transportation. We measure the data, we found there is nothing when these 2 containers, 2 box in 1 container, same container. In the ocean, during the ocean transportation, very quiet. And everything happens is the loading, unloading, road transportation, loaded up and loaded on, road transportation to the end. This is from Suzhou, China, to Michigan, United States. Very long journey. So they have a lot of road data as well. So we found results from this testing. So this is an example how we find the difference with the airbags with also the EPE foams. Finally, you will make your selections for which one is suitable for my product. Okay? Because of time, I just want to simply say, optimize the protection vibration. This is the vibration for profiles we measured from the whole journey for different isolation. It's airbags here, that, and this is the foam cushion. So you will see there's all different FNs with different materials. You easily think the airbags is softer than the EPE foam, because EPE foam with a preload press on, they will have less room to move. If the airbags, they have a preload, they expand it a little bit, but still have a good distance to move. So this is a 2 physical difference for these 2 materials. So finally we found airbag has a very lower FN reaction, which we heard also very good from our truck. The air truck and the spring truck has different resonance. This is the same result we have. So this is fine. So after this, we check the shock events. We find the air cushion has higher shock compared with the foam. Because the foam, they absorb the shock better because the distance is small, so the shock is not being heated up, it's just absorbed all the time. So we'll see, because the same time map, and then you can see the same time being shocked, and then you can see two boxes will have the different reaction. So this is something we found in this. So we have the conclusion. Airbag supplies advanced vibration protection, but EPE foam has better shock absorption performance. So for this customer, it's a very famous customer, Applied Materials. They have a very specific load in this box, and they said, okay, finally, they choose the EPE foam because they're very care about the shock. The vibration they measured in this journey, they don't think it's a hurt. So finally, they optimized, they change a little bit for the foam density to make it more supported. So finally, they use the foam from the packaging. So this is an example for shock and vibration, how you optimize your choice to make a better for yourself application.
David, 2 minutes.
Yeah, thank you. Almost there. We have a summary. To optimize packaging design to pass the final performance test, to understand whether the test protocol is suitable for future transportation. And you're going to say, enhanced simulation for my packaging system, is it good for my future transportation, environmental? This is very important because if I will not go this ocean shipment, should I test the ocean shipment test protocol? No. If I just ship a short distance, I don't need to test long distance. So why the ISTA profiles is going to higher 0.54G? Because I measured it's only 0.0 something. Because they're shorter, the time of testing, but strengths, the level of the testing. So this is all things being understood by you first, and then you go choose the right test standard for yourself. And the second, you should really understand the factors for how this test was failed. Then make the product physical testing, not only the environmental testing, but think about materials. And after that, make the packaging material, test it, and trust this material is suitable for you. And then you combine all the results to change a little bit your testing, your packaging design, which is, we call it optimized, but it's easy word, but it's not easy work. Not for me, at least. So we look after also the box and the materials of foam. We got to press, can see the pressures and how many force they can bear. And we got to use all those testings, which is not Lansmont range. But we all need that, how bend, force they are. So this is what we're going to use for this testing. Okay. Finally, it's a short video for a couple of minutes to show what is the journey packaging of the plastic bottle. Start with the plastic raw materials.
From concept to consumer, take control of your complete product journey.
Thank you. This is all my
In this
presentation.
video, we will take you on a quick tour of how products are meticulously tested and packaged, ensuring they reach your hands in excellent condition.
For the ideas I was just shared.
We're going to
Just
follow
find
a
me
plastic
around here.
water
I will
model
stay here
and how
for all day.
PPT Group's cutting-edge test instruments play
Thank
an
you very much
indispensable role in
for your
ensuring the
time.
quality, safety,